Hello everyone, and welcome to Bad Password Analysis and the NIST Guidelines. If you 50 years ago needed to come up with a secret password, you were probably part of a secret espionage organization, or more likely you were pretending to be a spy when playing as a kid. Today, many of us are forced to come up with new passwords all the time when signing into sites and apps. As a password inventor, it is your responsibility to come up with good, hard-to-crack passwords. But it is also in the interest of sites and apps to make sure that you use good passwords. The problem is that it is really hard to define what makes a good password. However, the National Institute of Standards and Technology knows what the second best thing is to make sure you are at least not using a bad password. So in this project, we will go through the rules in NIST Special Publication 800-623B, which details what checks a verifier, what the NIST calls a second party responsible for storing and verifying passwords should perform to make sure the users don't pick bad passwords. We will go through the passwords of users from a fictional company and use Python to flag the users with bad passwords. But us being able to do this already means the fictional company is breaking one of the rules of 800-623B, which is verifiers shall store memorized secrets in a form that is resistant to offline attacks. Memorized secrets shall be salted and hashed using a suitable one-way key derivation function. That is, never save users' password in plain text. Always encrypt the passwords. Keep this in mind for the next time we are building a password management system. Let's load in the data. But before loading the data, there is a note I want to highlight, which is the list of passwords and the fictional user database both contain real passwords leaked from real websites. These passwords have not been filtered in any way and include words that are explicit, derogatory, and offensive. So let's start our project. Let's import some necessary libraries. Import. But for that, I'll prefer commenting. So, module. Noting the datasets. And set. So let's print out how many users we have got. Printing out how many users we have got. Print length users. let's take a look at the 12 first users. So taking a look at this. If we take a look at the first 12 users above, we already see some bad passwords. But let's not get ahead of ourselves and start flagging passwords manually. What is the first thing we should check according to the NIST Special Publication 863b? Verifiers shall require subscribers chosen memorized secrets to be at least 8 characters in length. Okay, so the passwords of all users should not be short. Let's start by checking that. So let's calculate the length of user's password. The length of user's password. String dot length. Let's check what has been stored inside. So okay. Let's now flag the users with two short passwords. So flagging the users with two short passwords. Too short. User length according to the rule should not be less than it. So control literal user okay. Too short. Okay, so now let's count and print the number of users with two short passwords. Counting and printing the number of users with two short passwords. Print users to short. I'll call dot some method. So 376. Let's take a look at the 12 first rows of the users. Users dot head, and before that I'll comment taking a look at the 12 first rows. Already this simple rule flagged a couple of offenders among the first 12 users. Next up in special publication 863b is the rule that verifiers shall compare the prospective secrets against a list that contains values known to be commonly used, expected, or compromised. Passwords obtained from previous breach corpuses, dictionary words, repetitive or sequential characters, for example AAAA 1 2 3 4 ABCD, context specific words such as the name of the service, the username, and derivatives thereof. We are going to check these in order and start with passwords obtained from previous breach corpuses, that is, websites where hackers have read all the users' password. As many passwords don't follow the NIST guidelines and encrypt passwords, there now exist large lists of the most popular passwords.